Hi, I'm Brent Sherwood. I work at JPL doing a lot of the things Knut just talked about. I manage strategic planning and business development. The office is called Strategic Planning and Project Formulation. It includes a capability that we call TeamX. It was invented at JPL, as Knut said, in 1994. I'm going to talk a little bit about what it is, how we use it, how much we've used it, and what I'd like you to help us with as we move into the future. So the purpose of TeamX is to operate in the phase of a life cycle you see here on the left-hand side. If you have an idea that has to do with the kind of exploration you want to do on Mars, at the end of the project life cycle, you're going to be operating on Mars. That shows the Phoenix lander that's en route to Mars. It enters the Mars atmosphere on May 25th. But it began 5 years ago in the TeamX environment. It's before we even get into phase A, when we're just playing around with the concepts and trying to do engineering based on the concepts. We use TeamX for the entire spectrum of concepts we develop at the lab, ranging from mission architectures to mission design to the development of concepts for specific engineering concepts for flight systems, that is the spacecraft themselves, the instruments, and so forth, all the way down to the optical design of new telescopes and so from the detail all the way up to the mega scale for the types of missions that we do. We've done over 800 studies in the last 15 years, and as Knut mentioned, this has been much copied around the world. Elsewhere at NASA, a lot of universities, all the major aerospace companies use environments like TeamX now. Here you see photographs of our new facility we just renovated last year, and this comes under the category of, you'll hear it either called extreme collaboration or collaborative engineering or concurrent engineering. My definition is very simple. It's the right brains in the same space, notice I didn't say room, but in the same space, operating on shared data to yield an integrated result very rapidly. So we can develop a conceptual design to a great deal of engineering detail for a mission in a total time of about 6 to 9 hours. This shows the configuration that we use now. You'll see we put about 24 people in a fairly small space. It's a tailored environment, so they're isolated from the rest of the offices and distractions. They all have workstations that have software loaded on them to enable them to run their specific subsystem models. And they share information, so there are multiple view screens. It's very much like a mission control for concept development. And it enables them to use rapid visualization and the sharing of data so that they're all working toward the same goal, even though they're all doing different work in the service of that. It's a very intense environment. So I call it the meta brain. This is a collective brain, 24 people doing the same thing together in just a few hours. Well, here's what I want for the future. I want really rapid visualization. Now, we do visualization at JPL for very specific things like astronautics that nobody else in the world needs, so we develop those tools ourselves. And there are some tools for CAD development, of course, but I need CAD that's based on libraries where I can design a mission system in 2 hours, not 2 weeks. I also need advanced visualization of integrated system performance, the modeling of an integrated system. I want genuine multi-view 3D imaging. Remember in Star Wars, they're all sort of sitting around and they're watching the battle space and they're having a battle strategy or battle tactics discussion, actually. That's what I want. I don't know if it's holographic or what it is, but I want it in that space right there in the front of the room so everybody is looking at the same thing in 3D. I want seamless integration for face-to-face behavior that's remote. So when I integrate with 6 other NASA centers simultaneously who are spread around the country, they're all operating in this 3D environment. And I want intuitive user interfaces, both graphically and for what I see, what I take in visually, and how I control that system manually. I don't want a mouse. I don't want, this thing I just saw, this haptic thing looks kind of interesting. But I want more of that. And ultimately, because I'm a singularitarian, I want to get past the singularity so that I can take those 24 brains and actually integrate them, literally integrate them, through artificial intelligence systems so that I genuinely have a collective brain doing this design together, because we all know when we're designing something it works best when we're able to keep the group that's doing it very, very small. I'd like to take 24 people and make it one collective brain in that space. That's mine. Thanks.